Hello, everyone. So we're going to start reviewing for the exam today. Isn't that awesome? Why are y'all laughing at me? There's no way I made a mistake earlier. So, anyways, so what we're going to do is review for the exam, and under assignments. Oh yes, the announcement. Is that? Oh, thank you. Yes, that I pushed back the due date for the homework and the quiz for a week, and then the exam for another week as well. So then the exam would be not due this Friday, but the next Friday. I would still recommend that you take it this week, but that's up to you. Okay, was that good? I rehearsed it and everything. So what we're gonna do to get to get ready for the exam is go through the practice quizzes, much like all the other classes that we do, because this is password protected, right? And there's not a practice exam because then we would be cheating, and I've been told not to do that. I mean, we don't do it for any other calculus classes, so you know. So we're gonna go through the practice quizzes, and they're great. And remember that I just made this exam, and I recall vaguely what was on there, but I also want to just like this looks good. This looks like legit, and then oh, not that one, that kind of thing. I got to say, most of them, if not all of these on the practice quiz, are pretty legit. Maybe not this one; it's too easy. But regardless, let's go through some of this, and we got plenty of time. And if it's similar, we'll just skip it, right? Because it's 63 of them. We don't really have to do 63. What would be the center of this guy? And then the radius is? I can't check it. That's okay. You can. You want me to show you how? As if we just can't get it perfect for you. Also, another funny thing you might want to mention to them is that the practice quizzes actually affect your overall grade. Because on
No.
mine, I have a higher grade than what it says I currently have, but it takes into account the practice quizzes
Okay,
as well.
then I will delete that ability. You're gonna remind me.
That's not how it should be.
That's why I did it.
Yeah.
Restricting how much I want to do.
We will definitely fix that. I am sorry. That is not good. Anyways, this one, same thing. I think this is too easy. Like this one here, it's not too easy, but I don't remember it. I'd like to just quickly do it if y'all are okay with that. Cool. Let's do that. Sure. Factor. That's good. Yeah, that's the word. That's the word I would use. Not really. Complete the square is what I would use. Yeah. Oh, it's not fun anymore. Yeah. Yeah, I don't recall seeing this, but I mean it's good practice. There's no other whys, which is nice. Okay. So yeah, we're trying to find some numbers that go right there. Remember that we take that number, we divide it by 2, and then we square it. Yep. And so that number would be a 4. Take this number, divide it by 2, and then we square it. So that would be a 1. And this portion is the square that we're looking for. X plus 2 squared, y plus 0 squared, c plus 1 squared. And then we have a minus 5, so I'm just going to toss the 5 to the other side. And then we're done. We're ready. Ba-da-da-da-da. Bump. Ba-dump. Cool. That one's too easy. Maybe I should put it back on the exam. Yeah, I think I skipped these because they were pretty simple in the end. And they're not really what we're testing over in this class. Overall, is that okay? Let's keep cruising. Let's see what else we got. Yeah, I'm bored of those guys. Boring. So again, very simple. but it's also foundational. I think we could probably do this. What if I add those two vectors together? What do you do with these two vectors then? Not cross. What do you do when there's a plus sign? Oh, you add? Oh, well, that's pretty easy. Gosh, why is that on our exam?
Hey, we need something to at least bring up our grades to try and get the harder questions, you know?
And then magnitude. I wonder if they'll take this. It is an exact answer. I was being nice even. I didn't put any squares in there. We'll see. I'm going to submit it later, of course, and just see what they say. That's a 9. Yeah, and if I scribble more on it, that definitely helps. Now it looks like a dog. Real quick, let me get rid of this thing. I'm sorry. This, and now don't tell my math lab I just did that. Anyways, it just gives me more room. Are y'all okay multiplying and minusing, adding? Yeah, I'm not gonna spend time if y'all are good on that. Easy stuff. Yeah, I think like there will be something like this. I recall something like that. Ah, now this is different. You want to do it? Good. Just refresh is fine. Okay. Sweet. Yeah, yeah. Well, so here's north. This is west, and we're going 25 degrees from north to west. And then we're going to draw an airplane. Vroom. Pop, 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 pop. Okay, so we got an airplane. Okay, find the component in the x and y. 500. Oh, that's not too bad. What's the true angle from 0 going to be?
Wouldn't that be 90 plus 25?
Perfect. Thank you. All right. There we go. And so then I think it's just going to be 500 cosine of the 115.
Right, because it should be the r cosine theta.
Uh-huh.
Yeah.
Yeah. Easy peasy. 1 decimal place. So here we go. Desmos time. And make sure you're in degree mode for this one. Yep. It says 1 decimal. Nope, that's a 2. Okay. Y'all okay with that? That was good? Okay. Cool. Let's keep cruising. Ah, yep. There we go. Is this on your exam? Probably. Probably. Yeah. Well, then skip and come back.
Wait.
What?
Will Chad remove it if we all get it wrong? I'm joking, of course.
I'm thinking though. So we have 1 this way, and 1 this way. Wow, that's great drawing there, Chad. Start that over this. So if that's 30, then this is 30, right? And then if that's 50, then this is 50. Then we have a straight down at 500. So the true angle for this one then, like going all the way, 150? 150? Right? Because 180 is total?
Yeah, subtracting from 180.
Yes. Yes? Confirm? Okay, good. So yeah, let's try to figure this thing out. So I need, let's call this A and B, right? I know F1, F2. I'm just going to do A and B because it makes it a little easier. So I got A cosine of the 150 plus B cosine of 50 should equal 0. Like the x components should cancel each other out. The y components eventually will cancel, but see, like minus the 500 and then equals 0. So those are my two equations now. Oh, good. Oh, cool. I would say yes, because like I also taught it, of course, back in the day. But I think I'm going to solve for B. So then I have B is equal to a negative A cosine of 150 all over cosine of 50. And then I can plug that in right there and solve. So then A sine of the 150. Then I have negative A cosine of 150 sine of 50 cosine of 50. I'm seeing a pattern equals 500. I'm moving this guy over. Factor an A out and then move it over. So they both have A. What is sine over cosine? Like in a way, this problem won't ever change. Does that make sense? Even like if I got another one, it'll still be the block weighing it down, two vectors, two forces. What we kind of made is a formula because I didn't actually, plug anything in. I just said, hey, what would this be? I mean, could you maybe possibly put that on your formula card? Not this specific, but you could put, say, like theta A, theta B, something like that. It's a thought. Okay. Wait. No. We're good. We're good. Yeah, it's 100%. We're good. We're good. Why does it not like that? Is it because I need parentheses every time?
Oh yeah.
I'm happy with parentheses. Okay. 326.35. And then I can take that and plug it into my formula up there. So negative answer times cosine of the 150 divided by cosine of the 50. Okay. Are y'all okay using scientific? Not too bad in the end. I'd like to switch back over. And I really want to know if I'm doing it right. Yes, Chad, I want to know if you're doing it right. What do we do for these guys? Basically just cosines and sines.
Wouldn't this one be for with the x part of the f1 and f2, aren't they? Well, f1 is negative, right, on the
Yeah.
x side, right? Okay.
Yeah. See, so we got a negative and a positive and a positive and a positive. I don't know if I like rounding, like using these numbers and then doing it, but those are those are literally the same number. No. Okay. Good point. See? Good point. Okay. Cool. You want me to hit submit? Okay. I don't mind. Too bad I can't hit submit because I got rid of the bar. Well, good thing I could scroll down to the end. Submit. And we got it partially right. What did I get wrong? Ah! Would you give me a point for that? You would? Oh, okay. But I only had Desmos. Hi. Okay.
Well, you worked it out on a piece of paper.
I did? That one? I got up to this point. Sure. If you say so. I give me one more second to get rid of that stupid bar again. Yeah. It's like you have to use code to manipulate. Okay, where's that one we just had? Okay. Cool. Then let's do it again, right? But now I got answers. Mwah. I wonder, is there an easy way that I can just do the... No, because this one's wanting an angle instead. Oh, that's mean. Okay, well, erase. Start over.
That one you had to use the knowledge of the forces, which you gave to find the angles.
The knowledge of the force? Sis? Sorry, it just sounded so epic. Yes. Yeah. So this is alpha. So then, and this is 57. So then this would be the 180 minus alpha kind of thing. It says F1 is 39, and that this is just, I'll call it B, alpha beta. There you go. So then I got 39 cosine of the 180 minus alpha equals, right? Because they should be the same, equals, because it'll have to be a negative. I'm just going to still put a B, or a plus sign, B cosine of the 57. All right, awesome. And then, of course, for the other side. Okay, cool. This one's a little bit more difficult because we have the alpha we need to solve for. If I try to get this by itself, no, I want to solve for B. Yeah, this one's not as fun. We're going to see what I can do. And if it's terrible and I can't do it without a calculator, then we'll know now. And then I'll change the exam. Because I can do that. I wouldn't want you spending so much time on just one little question when they had, originally intended it to be something more calculator driven, if that makes sense. I don't know. I mean, in theory, none. No, I do want a negative there. It is a bold theory. Oh, you know what? I have an idea. No, let me show you. We can do this one. We can definitely do this. I have a good idea here. Cosine of the 57, and up here we have a sine of the 57. So there's that tangent thing again. Hang out with me. Here we go. I guess I could do a minus sign now. Okay, and then we have a tangent of the 57. Okay, I need to solve for alpha, right? So it's convert this over. Let me think about it for a second. No, I don't like it. All right, so it's not good test material. Can y'all remind me to delete this if it's on the exam? I mean, it might not be there, but I just need to make sure. I can't show you with the recording. Are you so sure about that? Yeah, I would say at this point this is all just calculator stuff. Really? The homework said that? But this didn't? Okay, well now we know. Yeah, that's just not worth our time. Let's keep cruising then. Similar design. Can I look? Because I'm just finding the two forces. They already give me. Oh, yeah. If you're finding forces, you're fine. Okay, I would say that's similar to the other ones. Let's keep cruising and see what else we got. Okay, this one, yeah, this one's definitely going to be on there. 100% sure. Reason why is because it does a little bit of everything, so it hits up all the hot topics, I guess. Can you dot product these guys? Magnitudes? Easy enough. So it says the cosine of the angle between them. They mean that formula. And so, like, let me write that down. Oops. Yes. Okay. So yeah, cosine of theta is equal to u dot v. And that's probably why they wanted you to find the magnitudes earlier, right? You need all those components up there to put that together. And then just arc cosine, so that's easy. Scalar component of u in the direction of v. Is that like the projection magnitude? I can't. Was there a formula we had for that? The scalar component of u, but in the direction of v. That feels like to me it's going to be this projection stuff. Yeah, let me real quick and let me check that out. Okay, clear. So if I do square root of the squares, so 9, 64, and 2, and then if I did 5 times square root of 3, yeah, that's what it is. It's the magnitude of that projection. So then basically we need to find the projection, and then we just find the magnitude of it. Is that cool? Okay. I feel like I'm losing steam up here, guys. I'm actually like really hungry. And I didn't realize I was hungry until just now. Go ahead. We're going to find this first, and then I'm going to go back and find the magnitude of this guy. Yeah. So the projection formula, and don't quote me, but I'm writing it down, I guess, is... Okay, I'm lost. Oh, u dot v, v dot v, v.
Yes.
Ah, this is weird, isn't it?
So this one contains around the formula of cosine theta equals blah blah blah.
Cosine theta.
That's what I have written down here in my notes, but this may not be the most accurate thing. I'll be honest.
So another way we can do this is the u dot v, which we have. This is the magnitude of v squared down there, and then just multiplied by v. And then to get this guy, we just need the magnitude of my answer. So I would say this first, then that. Okay, so U and V, here we go. I'm going to see if I can get this. I already said, can you find a dot product? And you said yes, and then we didn't do it. So 3 and 3 makes a 9, negative 9. 8 and 8 makes a 64. And then the two square root 2's make a 2, which we already had this earlier, didn't we? 11 plus this would be a 75. Is that right? I hope so. It'll be fine. That looks great, Chad. Great, Chad. Yeah. All right, magnitude of V, they already said is this 5 square root 3, so that's very nice of them. So here we go, negative 75. Didn't they get an answer right there? Look, they already had it for us. Happy days. I love cheating. And then multiplied it by, oh, my V. Look at my V. This is the V. They made V come first. I would use bad words right here, but I'm being recorded. I wonder, is this what they're looking for that scalar? I doubt it.
So
Go ahead.
the answer they got from what it looked like, 'cause it was the bottom one, right? The answer I got was with the scalar and the magnitude of b squared, it came out to be.
Go ahead.
Never mind.
Oh, okay. So what they're doing for this formula is they're saying u dot v divided by magnitude of v for that scalar part. Not that, I mean, again, you could just go part d to part what?
You forgot to square on the decimal side on the calculator.
Yeah, I know that's the answer that they wanted for the scalar side of things.
Oh, okay.
That's part C, essentially. And then we can keep going to find part D. I don't know. Blah, blah, blah. Lots of little parts. But are y'all okay with little parts? You're like, I'm not sure anymore, Chad. Well, if you...
I thought we were working with B because that's the one I was working.
I know, we should do D first. I was getting confused. So I'm moving on. Could I say that on my test? Well, I was doing the work and then I got confused. Moving on. Okay. But go ahead.
What did you actually do for that?
I didn't. No, I basically cheated. So, where's that numbers? Oh, they changed my numbers on me. So, anyways, I just used what they gave me, which was really nice of them. And then I went on the answer. Did you want to know? Did you want to know for reals? Perfect. Let's talk about it. So, what I was doing was trying to find what C is. The formula for C is just this. It's not. This is the formula for D. This is D, then this is C. If that makes sense. And so then, because we've already gotten the dot product and the magnitude, I could just divide them for C. Okay. At least I think that's how it works. Yes. Yes, that's how it works. Yep, that's right. That's your formula for C. This is your formula for D. And then you just plug them back in for this guy. Are you okay following the formula? I mean, basically, you have to have these to do them all, right? So you're cool with the dot, you're cool with the magnitudes? Once you have them, just plug them back in. Yeah, it's just a formula. But it hits up a lot of pieces. So that's good for exam stuff. This is legit, but we already have the formula for it, right? You want me to do it?
Sure.
Okay. One yes means a yes. I'm okay with that. I mean, I have plenty of time. I'm just running out of energy. Sorry. I should eat more often. I need it. I could drink some coffee. That's fine. I mean, 24 minus 8 is 16, isn't it?
Yes.
So that's my numerator, and then I have to find the magnitudes of each of those individually. 4 square root of 2. This one's way more complicated. What is it, like 100 or something silly? 60, is it 69 or something? 65? Couldn't just give me 4 more. And so then my arc cosine of 16, 4 square root of 2, square root 65, calculator done. Degrees. That's what I would say. Oh, not degrees. Not degrees. Radians now. Ooh. So mean. I'll look for that, of course. I've been bringing food to eat, but then I eat it in the car on the way here, so I don't have any left. That's good. Tastes good. Are y'all okay with that? Oh, of course. I can take as long. Yeah, no problem. Let me even get Desmos up so I know I'm not being silly here. Thanks. We should take our test collectively. What do you? Oh, I just said that. Isn't that more what it is in the real world, though? A group. Right, right. But I will have to say that software engineers work alone. I'm hoping that they didn't hear that over there, okay? Yeah, yeah. That's funny. Yeah. Exactly. We did something like this already. Actually, this is just horizontal vertical components. So that's just sine and cosine, isn't it? Right, but it doesn't even ask for how long in the air. It's just saying, hey, cosine and sine, isn't it? I'm not worried about that. Okay, that's good. This one is a little different. I'm always intrigued because this is definitely physics, right? But I have no clue how to do it. So let's try that. Oh yeah, that was actually, I'm the one that created those problems in Intro to Engineering. Yeah, you could totally blame me for your problems. Like, I'm not kidding you. I made those up because it was like similar to Rabbani's class. Exactly. Yeah. Yep. So it says that find the force W. Okay. Incline plane. Yes. 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 And so if it's no longer 33 degrees. This is now 22 degrees. Am I correct? Because basically we tilted it down. Yes. Yeah, we went down. We went this way 11 degrees. So now that's 22. And so then I would only want, it says parallel to the plane, so then I would only want the cosine of that. So then 2.6 cosine of 22. And this is why I have the practice quiz up with the answers, because if I mess up, now I know immediately if I messed up, and that's a good thing. You wouldn't want to go through the whole thing and say like, oh man, I messed up 5 years ago. You can, it would just take a lot longer. But you can go in and out, in and out. I mean, I'm going to go fix that grading issue, but yeah. What? I'm not right. Oh, that is the X component. We're looking for W. Oh, well then you divide. You do this. That's what's going on. Yeah, let me try that. Okay, 2.6 divided by the cosine of 22. Radiant degree mode, there we go. Yep. You're right. See, I read it incorrectly. And this is also why we're practicing, so that I know ahead of time what to encounter. I mean, the problems will not change. You will not get any surprises. I mean, they're going to be the same things because I'm just limited pool, I guess you can say.
Class so far is there's no weird questions like in previous classes where they'll have like one question that might jump on an exam. But you only see it one time and it's completely gone forever.
I call it Poseidon's law or Poseidon's rule. Do you remember that? Oh gosh, that is so annoying. Yeah. It's not called Poseidon's. I just call it that. But yeah, it's.
At least I feel like most of the stuff that we've dealt with so far seems pretty well integrated.
Oh yeah, yeah. Yes. I can't have Poseidon's law or whatever here. So find the angle between two lines. They don't give me a formula necessarily. Which is fine. I mean, it's not a big deal. I would say find our two slopes and go from there kind of thing. Isn't there a formula with this, with slopes? I don't think we used it, though. Yeah, that's all right, I guess. Notice that they're saying AB, and here's your AB and BA kind of thing, right? So then I guess we can say it's like 1, 9, and is this one going to be the other guy? So would you say like 4, 5, 4 or something? Perpendicular to the line this and parallel to the line that. Nah, I'm just going to do it. So yeah, I think it's just going to be a -4, 5. And so then we're going to dot those. I think this might be the fast way. Let's just check it, you know what I mean? So that's my numerator. And so then I've got arc cosine of the 41. Magnitude of this guy is square root 82. And the other guy, 16 and 25. 49. 41. Oh, look at that. Let's try that. Again, if this works, I'll explain it. I just want to see, is this the quick way to do this problem? 41, and then square root 82, square root 41. No. Oh yeah, bro. Yeah, let's talk about this for a second. So what I did was I said this AB business. So A is a 1, B is a 9, A is a -4, B is a 5. And then there's your vectors. So dot product, and then magnitudes of each. Boom. That was fast. I think they were trying to confuse us with this whole like blah, 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 blah. Yes. Oh, you're fine. You're fine. You're fine. Should probably like separate these somehow. Go ahead. Yes.
organized. Yes, I agree. I agree with that. Yep. Yes, which is pile 4, obviously. Oh, it's time. Yeah, yeah. Let me just real quick look ahead. So another one of those. And then this guy. Oh yes. I don't think it's going to be this kind of question with this junk, but it will be. There will be area of a something on there. Parallelogram, triangle. They're the same thing basically. So that's definitely. Yeah. Yep.
They require you to make two vectors, one initial, so doing that with like Q or P, one of the numbers, and then finding the changes, then where you get the 2 lines, and then multiply by 2 if it's the area of a triangle.
So action items. Oh, so we're done. I'm going to stop the recording.